I want to use 2 minutes to explain everything you need about wave. And if you know this, you are good to go. Let's start. Now, waves, what is a wave? Right? I don't know why people cram this, but I don't want you to cram it. Wave is just a disturbance, right? I will tell you, I will give you an analysis. Wave is a disturbance transferring energy from one form to another without causing any permanent displacement to the medium itself. That is so easy. Now, for instance, if if you see a water, like if you see water inside a bowl, and by chance you just maybe perhaps drop a stone inside. A stone. This is a stone inside water, inside bowl. Now, if you drop this stone, you realize some form of movement, ripple movement, right? That is what we're just trying to say. If this ripple happen, it will just go from one form to another, right? It will not cause any displacement, any permanent displacement to this medium itself. That's what they are trying to talk about when we talk about wave, right? Now, there are properties of wave. Please, if you are writing WAEC, if they tell you mention 4 properties of wave, the last one here is the last you will mention, because I will tell you why. The number one types is reflection, the property reflection, refraction, diffraction, interference, and what? Polarization. So 5 properties of wave, but the fourth 4 is common to all waves. That is why. Now, polarization, this one is a JAMB question. Polarization, longitudinal wave, longitudinal wave, longitudinal wave cannot be polarized. Can't be polarized. This is a JAMB question. Can't be polarized. Please take note of that. I will tell you why as we move on. Okay, so please, longitudinal wave cannot be. So it's not common to all wave. You understand? But the first 4 is common to all wave, right? So how do I know it? R square deep. R square deep. R square deep. I want you to type that in the comment section. Type R square deep in the comment section. Let me see those that have watched it up to this level. Type R square deep in the comment section. So the properties of, just put R square deep. I already know what you mean. So reflection and refraction, diffraction, interference, and polarization. Those are the 5, right? Now let's continue. Now, if we have understood this, let's move. Now, wave can be classified into 2 classifications. Now, the classification number 1 is based on propagation, direction of propagation, and based on what? Material medium. The direction of propagation cannot be classified into 2. That's why we talk about what? Longitudinal wave, and what? And transverse wave. I will explain, don't worry. Transverse wave. Now, don't forget direction of what? Propagation. So longitudinal wave is when the direction of propagation and the direction of travel is parallel. Longitudinal wave is when the direction of propagation and direction of travel is parallel. Both the direction of propagation and what? And travel is what? Is parallel. That's when we talk about longitudinal wave. But when the direction of propagation and the direction of travel is what? Is perpendicular. Perpendicular. How? This is when we talk about perpendicular. When something moves like this. Okay, let me just give you a very good illustration to explain this. Just note that. Now, let's say we have something like this. For instance, I will use that water wave to explain again. We have pool of water, then you throw a stick inside. So you throw a stick inside, like you have a stick inside like this. Now, this stick here, you create a disturbance. Look at it. This direction of propagation, right? Now, it will not create a kind of ripple. Can you see? Now, don't forget, what do you observe? This is the way you hold this stick inside the water. Now, you see that the direction of propagation and the direction of travel is perpendicular. It's perpendicular. That is why this is a JAMB question. Water wave is a transverse wave. Water wave is a transverse wave. Please take note. It's a JAMB question. Water wave is what? Is a transverse wave. Because look at the direction of propagation is perpendicular to the direction of what? Travel. Direction of travel. Okay. Now, please note that Number 2 classification is based on material medium, if it requires material medium or not. If it requires material medium or not. If it requires material medium or not. Now, and that one is also 2. Mechanical wave and what? And electromagnetic wave. Electromagnetic wave. Now, mechanical wave, look at it. M, it requires material medium. M for M, material medium. Like it requires material. Like requires. But this one, electromagnetic, doesn't require material medium. Doesn't require material medium. That is, it just travels in a what? In a vacuum. It travels in a what? In a vacuum. Now, it travels in a vacuum. So when we talk about based on material medium, we have mechanical wave and electromagnetic wave. Based on direction of propagation, we have longitudinal wave and transverse wave. Now, there are a lot of examples, and that's where I'm going to stop for this video. Examples of longitudinal wave, example of transverse wave, okay? Because they are very, very important concepts that you must know. Examples. So, because I have some mnemonics I'm going to tell you. Now, for longitudinal wave, what are the examples? Longitudinal wave. First of all, is that sound wave is an example of longitudinal wave. Sound wave is an example of longitudinal wave, right? Please take note of this. It's very, very important. The direction of propagation and the direction of travel for sound wave is what? Is parallel. We already established that fact. For transverse, I know you should have seen transverse. When they say something transverse, so you can see that it's perpendicular, right? So a very good example is what? Is sound wave. Another example is the wave in spring. Now, I know why I'm saying no. Wave in spring. The wave in spring is also longitudinal. Now, I want to teach you something. Transverse. The number 1 example that you must know is what? Is water wave. Is water wave. Another example that you must know about transverse wave is the wave in string. And I know why I want to teach you like that. String. S-T-R. Transverse. Can you see? T-R. C-R. But this one is spring, and that's longitudinal. But this one is string. So TR is transverse. Do you get that? Very important. I don't want this video to be too long. Let's move. Now, look at it. For mechanical wave, we said it requires material medium, abi? I'll also tell you another JAMB question. Mechanical wave